Welcome to today's presentation, Fast and Reliable Edge Computing Automation with Chef, Drive Business Agility at the Edge. Let's go ahead and get started. Eric, over to you.
Thank you. So first, we're going to review what the edge means, what's happening in that marketplace. Then we'll talk a little bit about how we can help with DevOps principles, what those look like for these different environments. And then finally, we'll close with what the Chef Enterprise Automation Stack is and how it's uniquely fits with some of the edge use cases. So first, edge, it's a new term. It's something we've been doing for a long time. I look at the term edge similar to what I look like for cloud. We've had a lot of cloud solutions well before we coined that term. We've had a lot of edge solutions well before this edge term has been coined. It's really referring to a computer near the action. So you probably have a computer that's maybe out in a plant, maybe in a restaurant, not in a clean data center out somewhere with the actual stuff that's going on. It's a growing market. 50% of large enterprises will deploy at least 6 edge use cases. Most people probably already have some deployment depending on their business, and that's just going to increase, be a more important part of your business going forward. So what's the anatomy of edge computing? There's a couple of different components. This is from Forrester. They break it down into edge, fog, and cloud. So the edge would be what we expect, like the IoT type use case or the edge computing point of sale system. It's some computer that's physically attached to something out in the field. It typically needs to be for some reason. Maybe it's attached to a printer, a screen, a mechanical device, a car, something like that. The edge devices will be the most numerous, potentially tens of thousands, hundreds of thousands, millions. And then those will all go and be aggregated through some other device. Forrester calls those fog nodes. This may provide some like essential services. Maybe they might aggregate 100, 200 of these systems, maybe caching, firewall services, so something that those all require. And then finally, they'll all report back to what is the traditional data center or cloud. Maybe that's where you do some of the long-term processing, storage of that equipment, of that data. So each of these will have their own constraints. So the edge devices may need to run in airplane mode, each which means like maybe they don't have full internet access or they don't have internet access all the time. Those edge devices may be responsible for like making cars, sandwiches, maybe customer experiences. The compute processing will also happen at the layer where it's the most advantageous. So you don't have to do all your processing at the edge. You probably just do the processing that is mandatory, maybe for latency at the edge. You don't have to do all your processing in the cloud. You just do whatever layer is the most appropriate for that task is where to end up. There will be a combination of all three of these for most deployments. And there'll be different types, right? It's going to be different based on what your business is. So each of those different examples I gave, like factory, restaurant, or maybe like theme park, they're all going to have very different needs they have, different technologies in place, but they'll have these similar constraints. You may be centralized, maybe localized. You may have a restaurant or you may have a theme park that has dozens of systems talking to each other, or you may have just like an isolated device, like one device in a store, one device in a pharmacy, or one device out in a plant. So there's just going to be all over the place for what is required. All these different use cases, though, will share some of the same constraints. This is from Gartner. They call these imperatives, but they're pretty obvious constraints. They're pretty obvious constraints that you may not necessarily have in your traditional data center or cloud environment. Some of these we really can't do a whole lot of, like the law of physics, the speed of light. This is just something that's there. You may have higher latency. That higher latency may negatively impact your applications or may require you to change the way you even think about application design, depending on how remote some of these things will be. Bandwidth isn't free at these locations. You may have a very constrained high cost bandwidth links out there. The bandwidth may also be like not very reliable. All of these are concerns that you probably don't have to deal with in your data center. Same thing for regulations. These things are physically somewhere. They may have local regulations that require additional concerns. These may be some of the most regulatory burdensome applications you have in your company. You may have PCI, HIPAA, CIS, TISA STIGs. They may be in very sensitive environments. Maybe they're controlling a power grid where they have to make sure that all these things are really, really carefully managed. And finally, another big constraint is anything that can happen, will happen, the old Murphy's Law. This is really expanded, though, when you have all these things together, latency, bandwidth, regulations, and combined with high scale. If you have 1 million devices, some percentage of those devices will always be down, will always be experiencing power outage, flood, or whatever external circumstances you have. It's not a clean room data center where you really have a lot of control over things. So these environments will have to be responsive to these constraints. And the constraints will, of course, vary based on your application. Maybe bandwidth is really your problem, not latency, but that you'll have these will factor into your decisions. So this environment, we've lots of customers in the space already. Like I said earlier, edge is maybe a new term, but not necessarily a new employment or new pattern. This is something that folks have been doing for some time. Folks may have been doing this for decades by now. We've all had to manufacture things. We've had to sell things. We've had to take credit cards. These are all been solutions we've managed. But there's just a bigger focus on this stuff now, and we can apply some more modern techniques to it. So what are some of the issues we've seen? So you probably have multiple configurations. We could call these snowflakes, where all these systems may be different if you don't have really hard policies of how to set them up. These are some of the things you can actually influence too. So the previous slide, those are just the laws. Like I can't influence physics, but I can influence how I set up things and set them up in a repeatable way. A lot of times, because things are set up all differently, it's very difficult for you to mimic those environments. How do you test for it when you don't even know the state that they may be in? You will require physical installations to add additional constraints to you. You can't just spin up a new instance and test on it. It may be a specific model number. You may have to find that specific thing and test on a specific physical device. Really relates to you spending a ton of time fixing these failures and unfortunately fixing these failures in production as well, not just on a test bench. Take all these problems and add that up, and it's going to make it so it's going to be a really low change rate. And in a world where this is becoming more important to your business, not being able to change it fast or at the speed you want can put you at a disadvantage compared to your competition. And the fact that you have such high scale can slow down deployment frequency too. You're not just deploying to one box, you're deploying to 10,000 or 100,000 boxes. That can take a long time, especially if it's unreliable. And since these devices aren't in a central location, those failed changes can be extremely expensive. You may have to send somebody out to a site with a thumb drive to fix it. You may trust your deploys so little that you won't do them remotely. You always require someone there, and that can be extremely costly if you're distributed across a large area, or maybe you're distributed in a place where your staff isn't. So you may have a lot of trouble actually updating stuff. You may not have good visibility into it. You require folks to log into systems and check and see if they're actually up. Really, this results in it being a high failure rate, very costly, and slow for your business. Okay, so let's do a poll. So you have a poll question out there. What challenges are you struggling with? I've just listed some of the challenges I've stated before. You should go ahead and see those challenges and go ahead and fill it out. I'll give you all a minute or so to fill it out. So the answers are, what are you struggling with? Developer productivity, deployment frequency, change failure, network, compliance, or inconsistencies. And I believe you can select as many options as you choose to. I'll wait a minute, and then we'll see the results on the next slide. So we'll have a little silence for you to answer. Okay, so that's about a minute. Let's go ahead and see these results. Okay, so looks like compliance is the biggest struggle. Not too unexpected. It's tough to have thousands of devices with maybe your highest regulatory controls in these environments where you can't access them and can confirm they're compliant. And consistency is tough. A lot of these environments have grown over organic growth. Maybe your business exploded and made you double these, and you weren't very consistent how you stood them up. And yeah, developer productivity is definitely something we see a lot too. These environments are constrained and different, and they're hard for you to really replicate for a developer. So what they're testing on may not represent what production looks like at all. And those differences you may not find until you actually deploy them, which is very costly and expensive. Awesome. Cool. Let's move on to the next one. So really, we have to take DevOps practices like the as-code model and apply that to this space, especially if you've had this space for some time and maybe you've used older practices like waterfall development to try and manage these environments. I typically have seen some of these environments that have been up for 5 years, 10 years. People may have homegrown tools and homegrown practices. There's really been a revolution in how we manage things, and that revolution can benefit these edge deployments and really start to solve some of those pains that we addressed in the previous slide. So I'll spend some time digging on what this means and how to actually do it. So how do you be successful? Really at the edge, you have a couple of different worlds they're combining. This is another stat from Gartner. Edge computing management combines data center management with the scale of mobile devices. So you sort of have the worst of both worlds. You have this massive scale, even bigger scale potentially than a data center, but you don't have that tight control. It's not in a space where you have like keycard access. It's out in the world somewhere. Maybe people can unplug it or they can access it. They can steal it. How do you combine both these things? And it's not quite a mobile device where it's just like a phone that's meant to be a consumer product. It may be like a very sensitive robot that is manufacturing sensitive things for you. So these two worlds are really difficult for you to manage. Same idea with the security risks. A lot of the security challenges of mobile computing with your data center as well. These are obviously talking to your data center. You have the same things like patching. These may be like normal Windows Linux servers, patching, configuring, deploying those servers. But also it's just out and maybe it's under someone's desk and they can access it just like you'd expect from a phone. So you really have to take best practices from both these worlds and apply them to your problem set. So this really makes it important that you have to design for operations. This is another quote from Computer Weekly. A lot of organizations don't have high discipline, I would say, for when they're doing these plannings. You may just get something out, learn as you go. You do need to apply some architectural discipline when you have such a scale and when you have a model that's going to be out in the field for as long as it's going to be. Some of these devices will have a totally different replacement model than you're used to. They'll probably be tied to the devices they're managing. Like if it's a computer managing a robot, that computer's life cycle may be more closely managed that robot's life cycle than like a standard data center cycle. And then that scale just makes any problem magnified. If it's in your data center, you can destroy it. Not a huge issue potentially, but these things may have to live there for 10 years and you may have 10,000 of them. So really, how are you going to manage in that day two operation becomes really critical for you being successful here. It could be the difference between this being a good project or a failed project. And this may be something you can't just buy from a vendor. So there may be vendors out there in their space that may make hardware for you. They may make the software for you. Maybe it's even like a solution you buy from them. You may not find a vendor that makes all those things together, and they may not have the management capabilities you need to actually run it. Maybe they might give you the software for the robot, but they're not responsible for the underlying operating system patching of the robot, or they sell you the hardware and you actually have custom-built software. You'll likely need to integrate these solutions, and this becomes important too because this is likely your core business. These use cases are way more important than just like traditional email for you. It may be how you interface with your customers, which is intrinsically tied to your core business. It's not something you can necessarily easily outsource to another vendor. You may really have to own this process. Cool. So I think this is the last analyst report that just talked about the industry and then how you should approach the industry. This is a really interesting one. If you haven't read it, it's the State of DevOps report published by Google. The link is there at the bottom. I highly recommend you read it. They measure successful organizations and what they do compared to their peers to be successful. And they boil down success into these 5 metrics. These 5 metrics define like software success, and they're absolutely still applicable for these edge locations. They're not just data center metrics. So what are they? Lead time, how quickly does it take you to get change out there? Deployment frequency, how often are you actually able to deploy? Can I deploy same day? Does it take me 6 months from the time that the business has asked for something for me to actually get that out? Change failure rate, what's the percentage of failures I'm having? So do I have 99% of my changes pass? Do I have 80% of changes pass? Do I have to do a lot of rework, maybe 20% of the time that they fail and I have to go investigate, find the issue? Change failure rate is really difficult when you have the Snowflake systems, and it's difficult when you have such a high scale. Even if your changes are 99% successful, if you have 100,000 or 1 million devices, that 1% is a huge number, and it can be really costly to have that number of systems either be down or need to be touched by a person to fix your deployment. That leads into the next metric, how quickly when you have an issue do you restore service? Is it something you don't find out till maybe the next day when your shift is there? Can you find it quickly and respond to it quickly? And then the final one is availability. How many nines available are you? Is the aggregate system up 3, 4, 5 nines? So this is just a really great way to measure your success for these edge deployments. This is how we'll measure the success for the rest of the presentation. I really recommend you all go check this out and honestly look at yourself and compare yourself to these metrics. It's really easy to overstate your performance, and then really you're performing poorly than your competitors, and that may be something you should investigate how to actually correct. I always like the story. If you ask folks if they're a good driver, pretty much everyone says that they're an above average driver. Of course, we all can't be above average drivers. Some of us are below average or just average drivers. And this is really the same for these IT worlds. Everyone says they're really performing better than they are. This report can give you some real metrics to go check out and see where you fall on the scale. Cool. So let's just run through a scenario and see if this sounds familiar to you. So it's probably after hours. You can't make changes during the day. You tried that and it didn't go so well. You have a rollout. Maybe it's a patch. Maybe it's a CVE fix. Maybe you have to make a configuration change. Maybe it's actually an application update. It's a new feature. Or it's a new blueprint or something, and it's on 10,000 system. Each of those systems may be different. Maybe you have 15, 20 different models out there. You may not know how they're configured. They may be configured through like different generations. They may be actually different operating systems. Their application version even may not match. And you may not know this going into the change. You may have some idea of what's out in your ecosystem, but you may not actually know, hey, there's these 11 models in play. And if you don't know they're out there, it may be really difficult for you to plan for them. You've probably spent days, maybe weeks, maybe months testing this in your lab. Your lab may have some representation of those things, but not exactly. It may not be in a state that mirrors production. So you don't really have confidence that you've accurately simulated those constraints. Your lab also may not be able to mirror those constraints identified in that Gardner slide, like the delay, the bandwidth, the physical location. Your lab also may be more reliable than you're used to. So you're anxious. Maybe you get sweat dripping down your face. Certainly probably a low point in your day. But you have to deploy. This is your job. And maybe it works, it fails, partially works. Probably most likely it's all the above. You have one of these conditions happening. And then you find out tomorrow when your plant is reopened or is not outside your change window. Hey, it worked great on most of your systems. Some of them you don't know if you even hit Some of them are down. Maybe they were down beforehand, and then there's just some you can't even find. So how are you going to manage this efficiently if this is your story? And top it all off, your business wants you to do this more frequently. They're demanding weekly changes or daily changes, and you can barely manage the yearly or the every 6 months velocity you're at. So this isn't too far. I mean, obviously some of these things are exaggerated, but probably a lot of these different criteria hold true for your environment. And it's really just something that's not sustainable. So how do we start to fix this stuff? So first, let's apply that DevOps principle I introduced a couple slides ago. Let's solve this problem as code. This is how high-performing IT organizations have solved their problems. This is how, like, the Facebooks of the world are able to have that massive scale they have. So define it as code. Code is trusted, collaborative, consistent. It really gives you a lot of attributes that you can't get with these older practices. And let me just switch. I'll share for a second, and I'll whiteboard a bit about what this process looks like for those who aren't familiar with as code. So first with as code, you start with a definition. So this is just the code, or you can also call this your specifications. What do you actually want to do? You would feed those specifications over to a robot, and then those robots would actually automate those tasks and like ingest those specifications and then perform them. Finally, you would then watch that robot to ensure what it's doing is correct. So this is really automation, or this is what we would call this as code model. Where you really get the advantage of this is you can take this code and you can apply it through a standard software delivery lifecycle. You don't have to become a developer, but we can borrow best practices from this world and apply it to these edge or these infrastructure use cases. You can take like a laptop or your standard environment, you write out those specifications, then you can take those specifications when you're happy with them after you've tested them and validated them a bit, and then you can do what's called a pull request to your version control system. I'll just call this SCM, source control management. This is probably like GitHub or Azure DevOps. That will then go through your software factory, which can include all of your different testing and validation approvals you may have. And then finally, this like validated set of instructions would be fed to that robot, which is actually out in the field performing these tasks for you. This is the as code model. And the last part to kind of complete our three-step process is you would then need to watch your robot to make sure that it's performing as you expect, it's compliant. So this is a real quick overview of what the as code model looks like. And I will show you a little prettier version. This is just what it looks like, more blown out and less whiteboardy. You probably have different environments you're going through, and you're using Jenkins or Azure DevOps to push you through this process of dev, testing, stage, then to production, with both automatic testing and then human gates. Cool. So that's the model, the as code model that we want you to apply. And then let's here's just a quick summary of what success looks like, or what you need to do to actually meet the requirements of these edge computing. One, to hit that scale, you're going to need something that's self-automating or autonomous. This is an area where you're not going to be able to tightly orchestrate it. You can't know that even those 10,000 systems are up, let alone that you have access to them at all times. It's an area where they really need to be able to automate themselves, self-healing. You probably have to have something that supports an air-gapped model or a highly constrained network model. They need to be self-healing and support roll forward, roll back, so you can quickly get back up and running without a problem. You need to treat all this stuff as code. So your configuration, your compliance, your application delivery. Once you do that, you can shift that stuff left in the process so you can actually test it well on your laptop. You get that control of version control. You can have things like peer review. And then finally, you need visibility in this system. Slides never. So you need visibility, see if it deployed correctly, and you need that visibility across your entire fleet. So did all 10,000 systems update correctly? Which ones didn't? How do I prioritize them? Another big aspect too is since most people mention compliance as a problem, it can be extremely burdensome to even collect the compliance data there. So you need real visibility into your compliance posture. So when those audits come up, it's not a month process to get it. You can just report it and send it over. And the last one, you want to be notified so your customers aren't the ones reporting these problems. You can find them and correct them before they get there. Cool. So how do we address these problems? So Chef, we offer the Enterprise Automation Stack. It's a set of tools that solve these tasks. And I'll dig into a little more of how we apply that to the edge environment. So the Enterprise Automation Stack, we provide really the set of tools that can automate your infrastructure, your compliance or security, and your applications. We wrap that with the dev experience and then some observability so you can report on those items. So that would be configuration as code, compliance as code, and application delivery as code. Some of the specific use cases of these that would apply directly to the edge environment, you're going to need a hardened base OS. You're going to need to make sure that system is compliant, how you actually do your deployments. All of those things are very important. Patch management, all those things we can solve in that as code model. So let's break this down into steps, right? So step one, let's start with config management. Before you can do anything with your system, it has to be configured correctly. Let's solve that snowflake problem of all those systems being different. We're going to start with Chef Infra. Chef Infra gives you a language to express how you want your systems to be configured as code. This is also sometimes called your desired state. On the right, there's an example of our code. I really look at this more of a specification. I want to install a Windows web server role. I want to install Apache. I want to start a service. You're really going to define what you require of that system into this format, and then we can apply that to your systems. So all those systems can take this. One big advantage here, too, is Chef does work in primarily an agent model, so it can hit those high scales. If you have 10,000 systems, 100,000 systems, that agent can automate itself. It can take this policy and ensure that system has run through that policy and report back. And it helps us survive things like, hey, what if 10 systems are down? What if the network's down and a whole set of networks or a whole set of my environment, the network's down? I don't even know if it's up. Like let's say we're doing a job and 20% of our fleet or 5% of our fleet's down. How do you know what systems were down? What do you do with those systems when they come back up? Do you roll the change out? Do you not roll the change out? The agent model makes that a lot easier. These systems are able to make their own decisions. They're resilient. When the network comes back, they will do their policy. They'll phone home. So that really helps you get to that scale. It also helps you for these high security environments where you may not have inbound access. You may not want SSH access out. So that agent's able to give you like a better security model and really just like a phone home style model that may be required. And last, this is on the right, this code is Ruby, but really it's just specification. So you don't necessarily have to be a coder to get there. You just have to be able to know your specifications to start to write them down. Cool. So once you've ensured that you can set up your boxes correctly, another logical step would be to make sure they're compliant. Before we put production workloads, we probably want that system to be compliant. And we will do the same thing. So very similar language. We can define what our PCI or HIPAA or CIS compliance policy is as code. Then we can apply those codes to the system, and we can see if they are or aren't compliant. This gives us a couple of things that are different than the traditional way of doing things. One, if we codify it, it's something that we can do at a machine speed, not at human speed. So I can do it every hour, every day. I can do it every day on all of my systems if I want to. So this can really become a continuous process where I understand exactly how PCI compliant I am at all times. A lot of the companies we work with, they really like that example on the bottom left, where hey, you have your Q1 audit, you're compliant, you don't manage your systems. They slowly start to become non-compliant. People change things. They get deployed wrong. And then, hey, it's time for your Q2 audit. Let's go do all this rework. Let's go log into all of our systems. Oh, let's find all the stuff that's not compliant and then redo that work. It's really like each audit. It's like Groundhog's Day. We're redoing the same activities. We really want to get you to the bar on the right. So you're doing these tasks every single day. It's not a big effort every audit. You've done that effort ahead of time. You can then slowly see that compliance go up and to the right as you're able to remediate more and more things. Another byproduct of doing compliance as code, we can then take this code and put it earlier in the process. So you're not finding compliance failures in production. Some places, maybe that's the first time a real scan happens in production, or your first scan happens very close to production where the change is pretty much baked. We can take these policies and shift them left all the way to your developer environment even. So you can ensure that every change will be compliant very early on in the process. If you need to have any course adjustments because maybe a developer's on a non-compliant version or turn a non-compliant setting on, you can make that course correction very early before you spend weeks or months in that development cycle. And then finally, that leads to a lot less rework. The worst case scenario is that you ship a change out that makes you non-compliant. Not only do you maybe have a compliance finding, but it's extremely expensive now to fix that in production. You have to go through that bad process we talked about previously. It may take you a long time. It may be damaging even to harden that stuff. So we really want to lower that rework and make sure you're always compliant. Cool. So last step. So we have our configuration out there. Our system is compliant. It is now ready for our application. So let's deploy our application on there. Typically, application teams are very familiar with this as code model. This is how they develop their application itself. But also, they typically don't use these practices to deploy their application. There may be several teams involved to deploy applications. Really what we want to do is apply those same development practices to how you actually define, package, and deliver the application itself. So the view on the top right, this is our dashboard. It just shows you the application definition. That's what does my application need? How do I start it? How do I build it? What are my dependencies? All those common things. We would then package that up into an artifact, and then we can deliver that artifact out to your various systems. The view on the bottom right just shows an example of your running environment. So once you've delivered it, is it up? Is it healthy? How is it configured? Those type of concerns. So how do we do this? So really, this process may, especially for an edge environment where you have high scale, you probably have several teams that are all working together to try and solve this outcome. Those teams may have unclear silos between them, unclear contracts. They may use different tools, and they may not really understand the full end-to-end process. So the first thing we're going to do is we're going to take that whole process. Some people may have it called like a run book. It's a list of things that have to happen for you to deploy your application. And we're going to take that left, and very early on, we're going to define all those things in a single place. So how do I build? How do I deploy? All those things are defined very early on, and that really helps us bridge to production. So we can test those things early in the process. It's not something that only happens in production. Once we have that stuff defined, then we're in a space where we can validate, and we feel really good that what we validated will actually work in production. Finally, when we deploy to production, we can see that it did work, and it's green and not red. To drill into a little more of that, so that definition is going to be your code. It's really just going to be taking that run book or those set of policies you have. Some of it may be tribal, maybe it's a Word document, and putting it into something that's actionable. That actionable code then will have everything your application needs. You'll then have an environment where you can test it. We call that the studio. You can type build, and it will take all those instructions, take that full definition, and wrap it into a signed and compressed artifact that's ready to be deployed. That artifact will contain the application, everything it needs. It won't be like a Rube Goldberg machine or a balancing app between several different tools with parts of your application. It's all there. Finally, then we take that and we can load that on one of your target machines. So you feed that artifact. That target machine has what we call a supervisor. It's really our robot. That robot can take the artifact, verify that it's signed, verify that it wasn't tampered with, uncompress it, and then it will follow the definition that you set for it. It'll follow those instructions on how to validate, how to install, how to run your application. And this is really what application deployments look like. It's a very simple, very repeatable process. It's also so simple that you can replicate it on your developer workstation. So you have access to that studio. It's really that clean room environment where you can build, package, and even deploy. Your clean room will have a little test robot in it that you can validate those steps and make sure they're working. So now developers can really simulate pretty much exactly what's going to happen in production in their own environment and have a high degree of confidence it's going to work. These same steps would then also happen during your builds. So we can remove a lot of complexity out of your build environment and define it here as part of your application. So that can be another big win for us. So once you have all this work done, once you have this definition work done, it gets really easy for you to integrate this into a more complex system. So you probably have an end-to-end pipeline like I showed you earlier, where you're going to want to build your system, deploy your system, promote systems, update systems. These can become quick and simple API calls to Habitat. So rather than Jenkins or Azure DevOps having thousands and thousands of lines of code and logic of how to do things, that build logic is just broken down to have build. And same thing for that upgrade logic. Rather than having a very complex 50-step process for how you upgrade, that logic's all boiled down into have promote. We also will have that logic for if you want to have, like, run this as Docker or in different environments. You can export these quickly to Docker as well. So all those integrations become very simple contracts. Awesome. So let's just summarize why Chef for application delivery and why Chef for the edge. So we can save thousands of hours of manual time. We can apply this model to these three problems, being config management, compliance, application delivery. We are architected in a way that's really advantageous for the edge. We mostly have an agent model. We're designed to be autonomous. We're designed for these high security environments where you may not have inbound access, like air-gapped environments or high security government environments. This model paired with our robots or our automation engine can really make you go a lot faster. You can start the test things quickly. We have APIs for pretty much everything, so it's really easy, like I showed in the last slide, for you to integrate it into a more complex pipeline. And then we can ensure that all this stuff is compliant. So we can, by doing these processes, the change becomes something that's repeatable for you. It's something that's really uneventful when it actually comes time to deploy. So we can eliminate a lot of those build time and runtime deployment failures. Finally, we provide a dashboard where you can see all this stuff. You can actually confirm that your change worked, that your system is compliant, that your system is configured the way that you want to. So one real-world example, and then we're almost to question. So a real-world example here is Walmart IRL. This is a great example of an edge deployment. They really have that three-tier like we talked about from the Forrester report. They have stores. The stores are their edge. Those stores are huge, and they have lots of systems in there that need to be aggregated, and they have data centers where they do processing as well. So here's a quote from Jeff Moody in the IRL lab at Walmart. Chef Habitat provides unparalleled flexibility and customization. Nothing else really does what Habitat does. I'd highly recommend checking out Walmart IRL. We have a page on our website. They, of course, have their own page. They're really doing some awesome things in the edge. Really some innovative stuff coming out of that group. Awesome. Well, that wraps it up for me. I will turn it over to Aaron for ChefConf, and then we can have some Q&A.
All right. Thanks, Eric. Just wanted to pop in here and let everybody know, if you don't otherwise know, that we are moving ChefConf from an in-person event that was going to happen in Seattle the first week of June to a digital event now. So ChefConf Online will be happening on June 2nd. And you can visit chefconf.io for more information and to sign up when we release more information on agenda and content and whatnot. So just had to throw that in there. So let's see. Feel free to ask any questions through the Q&A widget. We'll start with one here that is just, how hard is it to get started on Chef Habitat?
Yeah, great question. So we provide a lot of learning materials. There's a site called Learn Chef Rally, and we have a lot of examples of how to get started and what to do as you're learning. It's pretty easy. The hard part of all these projects is knowing what you want to do, that definition. A lot of times you may not know that, or it's tribal, so that initial discovery is typically the hard part. Once you know what you want to do, though, then it's pretty easy to write that in and write that into your code. But that's the difficult part.
Great. Second one here is, how scalable is this solution?
Yeah, great question. So we've really designed our stuff to be very scalable, 100,000 plus. Some of the largest complex organizations out there use us. So things like having an agent gives us a lot of that scale. The processing happens on the device itself, so we can hit some of the largest scales. I won't say we can hit billions like Forrester put in that analyst report, but definitely examples of tens of thousands, hundreds of thousands, even a little higher than hundreds of thousands. So we definitely have that model that's meant for those environments.
All right, great. I think we will close it out there. Thanks again, everybody, for attending today. Give everybody about 15 minutes back in their day. As a reminder, a copy of today's presentation is located in the resource list widget at the bottom of your screen, so feel free to download that before you head out. And you can also grab it by coming back into the On24 platform. The on-demand version should be available by tomorrow, and we'll send you an email with the link as soon as it's ready, and you'll access it actually using the same audience link that you're using right now. Of course, hope you found value in all the info that was provided today by Eric. So if you like what you saw, we definitely encourage you to share the presentation with your teammates on LinkedIn, however you see fit. So going to end it there. Thanks again, everybody, and have a wonderful rest of your day.